In exercise 23-2, we're given the names for several amines, and they want us to draw the structure of them. Now, these names could either be the first simpler way of naming, or the second way that always works, those two ways that we introduced in the previous video. You'll notice that that in this first one, where they say cyclohexyl methylamine, you'll notice that after the carbon prefixes, so hex or meth, after those you always have a YL after every single one of those. That's a sign that we're using the first way of naming. So what we're going to do here in this first way of naming, and again, you know you're doing the first way of naming if after every carbon prefix there is a YL. So in the first way of naming, amine is the backbone, and it represents a nitrogen and whatever hydrogens may be on it. Now nitrogen needs 3 bonds, so we'll draw those at the very least. Every carbon chain is named as a branch. One of our branches will be a cyclohexyl branch. Cyclo means it's going in a ring, hex means you have 6 carbons. A 6-carbon ring is a hexagon, and so we'll have a hexagon attached to the backbone, the nitrogen backbone. So that's a cyclohexyl branch. Meth means you have 1 carbon. A 1-carbon branch is just 1 atom there. The nitrogen still needs a 3rd bond, and so that 3rd bond must be going to a hydrogen. If it were going to any carbon chain, the name for the carbon chain would be named as a branch in this region here. And so what we have here is cyclohexyl methylamine. In B, they give us tricyclobutylamine. And again in this one, what you'll notice is that after every carbon prefix, the prefixes that tell you the number of carbons, after every one of those, you have a YL. And that means that we're dealing with the first way of naming amines. In that first way of naming amines, amine in the name represents the backbone, which is just the nitrogen and any hydrogens that may be on it. Nitrogen forms 3 bonds and has a lone pair. Should include that on this one. There's a lone pair on that nitrogen. And so, what are those bonds going to be 2? Well, we can look at the branches that are given in front of the backbone. We see the prefix tri. Tri means that we're going to have 3 branches, and they're all going to be the same type. After tri, we see the word cyclo. That means that these branches are going to be going in a ring. And after cyclo, we see bute. Bute stands for 4 carbons. So we're going to have 4 carbon rings. A 4-carbon ring looks like a square. And so each of these carbon chains will be a square. We're going to have 3 of them. So there's 1 carbon chain, another carbon chain, and a 3rd carbon chain. All of them cyclobutyl groups. There are 4 carbon rings, and they're all the same. So 3 4-carbon rings, that's tricyclobutyl. They're all attached to our backbone, the amine. So that's what tricyclobutylamine would look like. Okay, if you look at C, it's 2,4-diethylaniline. Aniline was one of the benzene derivatives that you would want to know. So it's benzene with an amine coming off of it. So benzene, 6-membered carbon ring with alternating double and single bonds. You have a nitrogen, and the nitrogen has 3 bonds total. We already have 1 bond going to the benzene ring to make aniline, and so this is going to be our backbone. Now, we don't have anything coming off of the nitrogen. If we did, instead of numbers, we would have capital N's. We don't have that, and so this must have hydrogens coming off of it, and that makes it aniline. Where the amine attaches, that's carbon number 1, and since we're drawing this, we could number this however we want. I'm going to number it clockwise. Now we're going to have branches coming off of carbon 2 and 4. They're both going to be the same type of branch. That's why we have the prefix di. And the prefix eth means that there are going to be 2 carbons in these branches. So on carbon 2, we're going to have an ethyl branch. That's 1, 2 carbons. On carbon 4, we're going to have another ethyl branch. That's another 1, 2 carbons in the branch. So we have an ethyl branch on carbon 2 and on carbon 4. That's 2,4-diethyl. The rest of this is aniline. And so that is what 2,4-diethyl aniline would look like. In D, we have a couple chiral centers. We'll worry about those last. First, let's look for our backbone. Now here, if you look at this one, you'll notice that, okay, in this first example, after your carbon prefix, you do have a YL, but after the second carbon-free prefix, hex, there is not a YL. And the fact that there is not a YL here is a sign that we're dealing with the second way of naming amines. In the second way of naming amines, everything, the word amine is not the backbone by itself, it's the suffix, and the backbone is everything after the last YL on. So the backbone here is cyclohexanamine. Let's draw that first. Cyclo means it's going in a ring, and hex means you have 6 carbons. A 6-carbon ring looks like a hexagon. AN means we have all single bonds, and the suffix amine means we have a nitrogen coming off of here. Now we know nitrogen forms 3 bonds, so there's going to be 2 more. And we don't see any branches with N's in front. Right? We have a 2 here, not an N. And so there are no carbon chains coming off of the nitrogen. It must just be hydrogens. So this is cyclohexanamine. Now we're drawing this molecule. We can number it however we want. Just the carbon that has the amine on it, that has to be carbon number 1. I'm going to number this clockwise. So 2, 3, 4, 5, and 6. Now, we have a branch. It's a methyl branch, and it's coming off of carbon number 2. The prefix meth means there's just 1 carbon, and so we'll have just 1 carbon there. Now what you'll notice is that what we've drawn is 2-methyl cyclohexanamine. But that's not everything. We haven't represented everything in the name. We haven't represented the chiral centers. On carbon number 1 and on carbon number 2, we have chiral centers. We have to make sure that carbon number 1 is an R and carbon number 2 is an S. Let's look at them one at a time. Let's focus on carbon number 1. We want to make sure carbon number 1 is an R. But the first thing we have to do that is to number or prioritize the different branches coming off of carbon number 1. So I'm going to put a star for carbon number 1. This is what we're looking at now. We want to make sure it's R. The nitrogen has the highest priority, so that'll get a priority of 1. To each side we have carbons. The carbon to the right is bonded to more carbons, so it'll have the second priority. The carbon on the left is the third. The fourth thing is a hydrogen. That's also bonded to this carbon here. So those are our 4 groups. Now if we just went from 1 to 2 to 3, we would be going clockwise, and that would be R. You can remember that because as you go from the top to the bottom of an R, you have to go clockwise. Well, that's what we want. So we want to go from 1 to 2 to 3 and not flip this backwards. To do that, we have to make sure that 4 is going away. Because if 4 were coming out at us, then we would have to flip this configuration. We don't want to flip it, and so 4 should be going away. If 4 is going away, then the nitrogen must be coming out at us, because with these tetrahedral atoms, you always have 2 bonds in the plane, one coming out at you and one going away. And so in that first bond, the one with the nitrogen must be coming out, the hydrogen must be going away, in order to give us an R configuration. Okay, that's carbon number 1. Now let's look at carbon number 2. That was just to the right of it. We want this to be an S, a left-handed version of itself. Well, the first thing we have to do is to assign priorities. We covered this a lot in the last video. And I have a lot of videos that assign priorities from Organic Chemistry 1. I'm not going to emphasize the process here. I'm going to assume that you are familiar with that process by this point. And if you're not, send me an email and I'll send you some links to videos that will help you master it. Here, this carbon to the left, because it's bonded to a nitrogen, if you draw the table out, will have the highest priority. The carbon going down, because it's bonded to another carbon after it, will have the second highest priority. The methyl group carbon will have the third highest priority, and the fourth thing that's bonded here is a hydrogen. Now, I'm going to put a dot here because we don't know exactly what orientation, orientation in space that carbon should have. But we know that the hydrogen is going to have a priority of 4. Okay, now let's think. If we go from 1 to 2 to 3, we would be going counterclockwise. That would be S. You can remember because when you go from the top to the bottom of an S, you have to go counterclockwise. Well, we want carbon 2 to be S. So we want to go from 1 to 2 to 3 here and not to have to switch anything. In other words, we want 4 to be going away. If 4 were coming out at us, then we would go from 1 to 2 to 3, get S, and then switch it to R. We don't want to switch it, so we want to make sure 4 is going away. If 4 is going away, then the other bond must be coming out at us. Because this atom is tetrahedral, it already has 2 bonds in the plane, one going away, the other one must be coming out at you to be tetrahedral. And so that is what the S chiral center looks like on carbon 2. Now we would erase these hydrogens because they're implied in the skeletal structure. And 1R2S2-methylcyclohexanamine would be this molecule here. Okay, last one, let's try E, orthoaminobenzaldehyde. In this one, we see the name for a carboxyl for a benzene derivative. One of the benzene derivatives you want to have memorized. The benz is suggesting that. So you draw a benzene ring, and what you have after it is an aldehyde. So an aldehyde coming off of benzene, that would look like this. That's benzaldehyde. Now we have only one other branch here, and the branch is an amino branch. That means it's going to be an NH2. But where should we attach it? We see ortho, and ortho means that the 2 branches are 1, 2. So, for example, and just for comparison, the ortho positions are 1, 2. Other options are meta, that's if you have 1, 3, and para, that's if you have 2 branches on carbons 1 and 4. So we have our branch, the aldehyde branch, that's part of this backbone name. Our other branch is an amino branch, so that's an NH2. In orthoaminobenzene, the NH2 is on carbon number 2. If it were meta-aminobenzene, it would be on carbon number 3. Oops. And if it were para-aminobenzene, it would be on carbon number 4. Well, we don't have meta or para, we have ortho, and so this is orthoaminobenzaldehyde. So hopefully this video gave you a little extra practice with naming amines, in this case going from the name to the structure.